Hello, and welcome to another edition of Code Remix Weekly. I'm your regular host, Sam. And this week, Tim isn't with me, sadly. He's off traveling to a conference again, I believe. But even without Tim here, we're going to have some fun. I am personally quite pleased to have upgraded audio. Now, I got one of these fancy microphones on a stick like a real YouTuber does. And I am personally pleased with how my voice sounds on this compared to the old headset. It's a subtle difference for other people, probably, but it's one of those things where the sound of your own voice kind of annoys you. And the old microphone was adding a kind of nasal, tinny quality to it that I didn't like. So this is a welcome upgrade. So without Tim here to banter with, I guess let's just get right into some announcements. And I will get those on screen right now. First things first, tomorrow, I believe, is the last day to register for this live event, which will be a discussion, a panel hosted by Ruse, and that will include Jonathan, Modern founder, CEO, as well as some really interesting folks from Uber, Meta, and Google. We'll be talking about the challenges and opportunities involved with maintaining software at great scale with huge code bases in diverse environments. So be sure to check that out. It should be, and there's an agenda here. It should be a good time. And then let's see. Wait, I had another. Yes, here we go. Then we have published a new video about JavaScript support showing using OpenRewrite recipes on JavaScript code, a long requested feature of OpenRewrite. It is also possible to write OpenRewrite recipes in JavaScript and TypeScript now as part of this. Even if you wanted to, manipulate Java files, you could write those recipes in JavaScript. So if that's your preferred ecosystem, have at it. Oh, and I shall drop a link to this in the chat for anyone who wants to jump to that. I should drop a link to the previous one, too, for that matter. So you could just go to the Modern website and find it there, but you might as well just click it right there. Okay, and then let's see. We just did a release of OpenRewrite yesterday, 8.66.1, and there was a 8.66.0 release just 2 days before that. A lot of bug fixes in here. A lot of stuff about JavaScript support has been a real has been a real focus of these past releases. Last I checked, I think one of the downstream recipe modules was having trouble making it through the tubes on Sonatype to the public Maven Central repository. So I'm not sure if that's been resolved yet. So some aspects of this release might still be in progress. Actually, let's just check if rewrite recipe bomb is out there. Is this one of the last things we release? Okay, yeah. So this was released 11 hours ago. So I guess we must have gotten the jammed dependency through the tubes and out there. So yeah, new OpenRewrite release out. A lot of JavaScript features, a lot of bug fixes. Check that out. Yeah. We upgraded to Cradle 9 recently, but that shouldn't have much bearing on anything. Okay, so today's main topic is type attribution. Type attribution is something we talk about a lot in OpenRewrite context, and we frequently cite it as a differentiator between something like OpenRewrite and tools that are purely based upon text or a syntax tree. Is that you can tell that a logger.info call is going to like an SLF for JLogger versus a logback logger or some other logging library in a way that a regular expression, simply could not, as it might not, be in the literal text of the code, the differentiating factor that would allow you to avoid false positives and false negatives about things. And so we are we have recently added 2 sections for this to the OpenRewrite documentation that are worth checking out. If this is not a subject you are already intimately familiar with and you are writing recipes that involve checking the types of things, there could be a lot of good information in here for you. And those two new articles, one is under, both are on docs.openrewrite.org. One is under, hold on, I shut my door. One is under the concepts and explanation section, which talks about type attribution at a high level, describing the concepts that are involved. And then the document that will maybe be more relevant for OpenRewrite recipe authors is under the reference section, and that is type attribution for recipe authors, which describes in a little bit more detail. Oh, door just came right back open again. Cats want to come in. Fair enough. This document targeted at recipe authors describes all of the classes and utilities involved in interacting with types in OpenRewrite. And so I thought we'd just kind of go through some of that today to try and prepare all of you who might be writing recipes to interact with these things, rather than just assuming that it works the way you think it does. Oh, hi, Kitty. This is my assistant Naz. He's here mostly to shed on things. Occasionally pee where he's not supposed to. He doesn't know much about type attribution, though, so I wouldn't expect him to be contributing to the discussion too much, except for perhaps a meow or two, which will be left as an exercise to the viewer to interpret. Okay, so the tip of the first thing that a recipe author working with types needs to know is that the type system is rooted in the Java type class or interface, which is implemented by several other interfaces. Java type is defined in the main OpenRewrite repository in the rewrite Java package, and at the top level, it is an interface which does not define pretty much anything in the way of shared behavior. There's a couple static methods where you could build a simple representation of a type from a string that could be handy in here. And there's a check for is assignable from to see if you could assign another type to that type. For example, integer is assignable to long without itself being a long because of primitive widening. But most of the juice here is in the subclasses of Java type. One of the big ones is Java type.fully qualified, which is a super interface implemented by a variety of other classes. Anything that has a fully qualified name is a Java type.fully qualified. And so that can be classes, annotations, parameterized, and that is just say parameterized with the type parameters, like list of T is a parameterized or all fully qualified. Then there's shallow class, which is a little bit more interesting, and unknown, something we, for whatever reason, could not determine the type of. And this is going to be a situation where OpenRewrite itself gets all of its type information back from a language compiler, whether that's the Java compiler or the TypeScript compiler or the Kotlin compiler. We leverage those for type attribution so that we don't have to go and figure out what the type of a given symbol is ourselves during parsing, as that is significantly more difficult and involved than just parsing the text into a syntax tree, which is part of why type attribution is not a ubiquitous feature of code refactoring or search frameworks, because you either have to do it yourself or integrate deeply with the internal APIs of the compilers, and that is the route we have chosen to take with OpenRewrite. So I guess one small note on shallow class, or you would get an unknown type typically if some jar that is required to, something that provides type information is not available on the class path. If you're using a Spring Boot symbol but don't have Spring Boot on your class path, a Spring Boot type might come out as unknown rather than something more fully fleshed out like a class or parameterized. And in those cases, the test framework, if you're looking at it with a unit test, would probably warn you that there were missing or malformed types in the LST, which we'll talk a little bit more about in a bit. So you won't see unknown very often unless things are wrong. Shallow class is a situation where you might be in a recipe, might not have the full definition for the type available. Like you might not have a type table or a jar, but you're like, I need to generate like a placeholder for a type, and I know the fully qualified name, and that's better than nothing. So you can a recipe can construct a shallow class mid recipe run. Sometimes, although typically if you're using a utility like Java template, this won't be necessary, and you'll instead get back like the fully formed class or parameterized as appropriate. And those, have on them not just the fully qualified name of the symbol you're looking at, but also all of the methods that are defined on that class, what its superclass is, what interfaces it implements, all of the all of the relevant metadata. Yeah, and so there's in this document describes some of the fields or differences between these things, as I have just summarized for you. Yeah, and this generic type variable for when there is a type parameter like T or question mark. And then aside from the fully qualified classes, there's also the array types, which bundle some other type in an array, and there's primitives for the various primitive types. And then one interesting and important one is Java type.method, where method invocations and method declarations have a bunch of type information on them. They have typically a Java type.class for the declaring type, so you can see the class the method is declared on, and then all the information about the method itself, its name, return types, its parameter types, parameter names, if it throws any checked exceptions, if it has any modifiers, if there's any type parameters specific to that method. And of course, there's also Java type.variable, which is where you have a field or a variable declaration. You might have one of these. And this can be convenient for telling the difference between like a field on a class and a local variable in a method. And these could even shadow each other, right? You could have a class with, well, I guess I can, Java. So if we had this, like this Scratch class, you could do something like this, and let's take off this static. Call you something else. And so, in here, if you're visiting, some identifier with type A, how would you differentiate between the A that is a class field and the A that is a local variable to this method? Now, you could, if you're looking at the AST, look for a this.a, there to be a field access, which would differentiate, which would clearly show that, we're talking about this one. But just in the type attribution itself, this identifier A is going to have a field type, which indicates that A is declared on class Scratch, that Scratch is the owning class for this. And this guy is going to have a null field type. If this shows up as a Java type variable at all. And then there are some slightly more niche ones, like intersection types, which, where you can cast something and say this is this variable implements multiple interfaces simultaneously. This is kind of rarely used in Java, but these intersection and union types are also show up in like the JavaScript LST, where these kinds of type formulations are a bit more common in that ecosystem. Having union types or intersection types is used more commonly in TypeScript than it is in Java. And so, but these same classes are used both in various language ecosystems, right? OpenRewrite started off in the Java ecosystem, so a lot of the data structures around LSTs and type attributions started from a Java lens and have been expanded to include those concepts from other languages. Although sometimes we rename them, right? I think multi-catch in JavaScript, even if this ends up being like the class that backs the data structure, I think we do call it, a union in if you're looking at it in the JavaScript LST. Cool. So that's kind of like what the different kinds of type attribution, look like. Uh, but how do you actually get at it? Right? Where is the type attribution in the LST? How does a recipe author interact with that type information? Are all pertinent. Knowing what the classes are and what their interfaces are isn't relevant unless you know where to get that information. And the way you get that information is that most typed LST elements, all typed LST elements, implement the typed tree interface, which has a get type and a with type method on it that will return a Java type and allow you to reassign the type attribution of the element should your recipe want to do so manually. And not everything has a type in Java. I mean, this method declaration has a type. This field declaration has a type. This class has a type. An expression. An expression like 2+1 has a type. So a lot of things have types, but not everything is typed. Not everything is an expression in Java. So like an if statement, this has no type, right? If you go look at the representation of if in the Java LST, you will not see, which is if you wanted to do that, it's the J class. And if we go look at J dot if, yeah, we would see that if does not implement type tree, statement does not implement type tree. So not everything is typed, but anything with a name, any user defined symbol has a type. Anything from the Java standard library has a type. And there's we have a list here of some elements that you can commonly expect to have types. Although there are some exceptions to these rules, like most identifiers are typed, but not every single identifier is typed. One example comes to mind is that import statements are themselves usually the fully qualified name of a specific class, but I don't believe they have any type attribution, at least not the last time I looked. So it's, you could kind of get into the specifics, get into the weeds here, but the most of the times you'd want to look for a type, it's there. And most of the times you wouldn't even think to ask for a type about something, it isn't. So, you could have a list that's exhaustive, but, a programmer's intuition is going to get you most of the way there in terms of anticipating what does and does not have types. So we talked about method invocations have a little bit, maybe more type information, or rather, of things that implement typed tree method invocations, and for that matter, constructor invocations are a little bit distinct in that if you just call get type on them, what is returned is the return type, which would be, what you'd be interested in for checking like assignability, like could I place this method invocation in this context? Is it going to return a variable of type that that is appropriate for this context? And if it isn't, then don't use it. But with a method invocation, you might be interested in something other than the return type of the method. You might be interested in what class is declared on, the name of the method, the declaring type, what the types or names of its parameters. And you can get all of that information with JDOT method invocation get method type, which returns that somewhat more involved data structure, which also includes on it the return type, right? So that's not information that is unique to get type with a method invocation. Okay, so there are some common operations for working with types that a class called typeutils, or to OpenRewrite to java.tree.typeutils happens to bundle up and make accessible for you. So if we go and take a look at some of the stuff in typeutils, it has a variety of just helpful methods. Anytime you're wondering, like when I ask a question of like, are these two types the same? Does the type I'm looking at match some fully qualified name as a string? You can use the stuffs in here like is assignable to check for assignability. You can use is of class type or is of type to compare types for equality. You can check if a type is an array or if a type is an annotation, or any of the questions you might want to ask about a type. There's probably a method in here that will tell you about that. And there's also this is well formed type method, which it might be at the root of. You might see this guy just checking to see that a type doesn't contain any unknown elements, and so this method participates in the test framework, telling you that there is missing or malformed type information in your LST. So if you, I don't know, are ever interested to make a test utility or something, then that would work for you. Look if we have any usages of the deep equals method. Must come up somewhere. Oh yeah, and there's some methods for writing out the types to string. Although looking at this, I'm kind of wondering, why is this here? Recursive types, type to string. This feels like something that could just be on Java type itself, but I'll have to investigate that a little bit later. So yeah. So type utils is handy for comparing types to each other. It could frequently be like the thing you're going to use most often in recipes is probably is assignable to, or like is of type, for just being like, is this thing the same as the other thing, or can I use this thing in a place where the other thing is what is expected. So those are by far the most common methods you would use off of here. But there are a couple other methods that are relevant. Like there's these type utils as class, as parameterized, as generic methods, which just do a check and a cast and return null otherwise. So these are just shorthand for, like, if we can look at one of these, there's a shorthand for an instance of check and return null if it's not. So if you'd rather, it's not obligatory to use these, but you might find that convenient in some circumstances. But even more often than type utils in recipes, you will see method matcher be used. Method matcher is a very common utility that we introduced early in OpenRewrite training classes, which checks a Java type.method or any object which bears a Java type.method, which is to say invocations and declarations of methods, for their declaring class, name, and parameters. And so you could do all of this stuff with all of these kind of checks with a method matcher or with manual inspection of the fields on the Java type.method. So these two code snippets are roughly equivalent in what they do. One uses a method matcher to simultaneously check those things, declaring type, method name, method parameter types with a method matcher and a single matcher.matches. Or you could check, is the method type non-null? Is the name a particular string? Is the declaring type list? Is there one parameter, and is it an integer? So this is obviously just longer and more involved than using a method matcher to do the same thing would be. But it's always maybe nice to demystify these utilities and see how they would work for yourself. There's situations, there are things you can't express with a method matcher that you might want to check if something matches a matcher and then ask some more involved question subsequently. Definitely done that before. But, in general, if you can use a method matcher, you probably should. It's terser and easier to read and just idiomatic. You can also check to see if a method, you can use type utils find overridden method to tell if the method you're looking at on one class is defined on that class originally, or is it implementing something from a super interface or super class. So there's type utils find overridden method for that. And then here is the kind of here's a couple tips we have about common problems that recipe authors run into with types. One of the questions we get frequently is why is import manipulation failing? Right? I have a recipe that said maybe add import or maybe remove import, but it didn't add the import, or maybe it didn't remove the import. Either way, the import's not quite how we want. And type attribution is almost always why these operations failed or did not behave the way you expected them to. Maybe add import won't add an import if nothing within the LST for that file you're looking at is attributed with the type of the requested import. So if you run your recipe and in your unit test, you don't get your import added, it's probably that your recipe, maybe it added, it didn't add an LST element with the type attribution you're looking for. And so maybe add import didn't add the import. And so this is usually corrected by, if you're using Java template, by supplying a Java parser instance to that template that has on its class path all of the jars which define the symbols used in the snippet is the main way that those come out with well-formed type information. Or if you were not using Java template and were maybe manually or hand constructing LST elements directly within your recipe, that might be a case where the import isn't getting added because you didn't add maybe you could construct like a Java type.shallow class, which is going to be better than nothing for type attribution, and then that'll get the import added. Relatedly, maybe remove import won't remove an import if anything remains with the old type. So imports not being removed when expected could sometimes be explained with like a recipe. Like if a recipe is like swapping out or like doing a library migration, right? And it's taking a class from the, from, I don't know, like Spring 1 to Spring 2, right? And the names of like the fully qualified, like, or maybe like a Java X to Jakarta is a better example, right? We're starting off with a recipe where there was a Java X import. At the end of the recipe, there should be a Jakarta import. And if that recipe did not change the types of all of the symbols in the LST from Java X to Jakarta, then maybe remove import won't remove the Java X imports at the end. So that's often what's going on there if your import manipulation isn't working. A well-formed recipe, these guys do accept a Boolean parameter where you could override the detection, or you could say, hey, always add this import or always remove this import regardless of what's in the LST. If you have to use those, like your recipe is, you just shouldn't have to use those in a well-formed recipe, right? Your recipe is probably buggy if you're reaching for that. So see if you could fix the type attribution rather than trying to manually override the behavior of these import manipulation methods, as they are quite intentional about what they do. Another common one, and I really should try to figure out a way to make this kind of error messaging better, is if your tests are failing with the error, like type is missing or malformed. And this can really happen for two reasons, and you kind of get the same error message either way. And that's if the parser you've supplied to the test cannot fully type attribute the before text. So like if maybe let's just open up a recipe module test. I don't know, what do we got open here? Yeah, I go over to RewRite logging frameworks. And so I've got like this wrap expensive log statements in conditionals test. I'll just revert my changes to this because they did not end up being necessary for the issue I was investigating. But yeah, so excuse me. We see that in the before text for these tests, we reference these SLF for J types, and that of course works because the test is configured with a Java parser that has the SLF for J API on its class path. So if we go run these tests, they will currently pass unless something else broke, but they should pass. Let's go think about it for a second. I should have switched this project over from using Gradle as the test runner to using IntelliJ, but I was since Gradle's the default, I have to remember to do that on every single project. Just a little bit tedious. There we go. Okay, right. So I ran these tests and they passed. But if I were to remove this from the class path, then we should get the type information is missing or malformed error. Yeah, and see this version is coming up before we even run the recipe, where it's pointing out that, hey, this LST contains missing or invalid type information, and it is for this test. It's citing everything in here that references, an SLF for J symbol is missing valid type information. Like, I don't know what logger is, because if you don't specify otherwise, the Java parser just has the Java standard library on its class path. And you also know, now I mentioned earlier, imports are not type attributed. There's no complaint in here about the imports, but there is one about this method parameter and the usage of this field, or the method parameter and the usages of that method parameter within the declaration. So, like this, this error has nothing to do with the recipe. This just has to do with the before. It's like, hey, before you waste time debugging your recipe, you like the garbage in, garbage out. You're feeding it a malformed test case, so of course the recipe isn't going to be able to do the right thing. And then the other form of that error is, see, do we have any usage of Java template within this one? Yeah. So like this recipe does construct code that uses SLF for J in it. So let's see. Yeah, so there's a couple of these. So if I go and break these, let's just comment out these Java parsers that are providing the type attribution. Here we are. So here's all the Java parsers used in this recipe. So now the before text is going to be parsed with a parser that has full knowledge of the type attribution. But the recipe, any elements actually produced by the recipe, will be missing type attribution. And so we'll see how the test framework warns us of this. Yeah, so now all of these are failing, and we're getting a very similar looking well, in this case, we're actually getting different text out of the recipe than was expected. So yeah, I was expecting we'd probably get type is missing or malformed, but the type is missing or malformed check comes after the check for the literal text being produced matching the expectation. So if we had not broken the recipe so thoroughly by removing these Java these Java parser class paths, we would have seen the type is missing or malformed error. Now, like many of the verifications in the testing framework, these can be overwritten. Like if I wanted to say, let's see, there are these type validation options that you could set on the spec. So you could say validation.none. Like you can opt out of these type validation checks. But again, most of the time you shouldn't want to, right? This reflects a real problem in the recipe. If you're trying to, if it produces something with missing or malformed types, then it can't compose well with other recipes, right? You can make a recipe that does not respect type attribution, that adds a bunch of text, to a source file that is all valid Java. But if it doesn't have valid type attribution in the LST, then if anyone tries to run your recipe alongside other recipes that might depend upon that type information, then those other recipes won't see the information they're looking for and won't be able to operate properly, which could really hamper them running as part of a larger composite recipe. And many of the most impactful recipes we have are these large composites of many other recipes. Like, here we go. I already have the Spring Boot best practices loaded up, right? Like Spring Boot best practices 3.5 is like 4,000 individual steps, right? Most big recipes are made of many small recipes. And if those small recipes mess up the type attribution, particularly if you're opting out of verifications, and all of the individual recipes tests could pass, but it could not work well in a larger composite if it mangles the type information. And so it's a lot. If you're running a bunch of recipes together like this, and some of them are not are producing invalid type information into the LST, then it could be very difficult to debug. Why is my large composite not making all the changes I expect? So yeah, missing or malformed type information could lead to the absence of an expected change, which is hard to debug, right? You don't like easily have a stack trace from an exception to go start hunting down. You just have an expectation that a change should happen that was violated. It's easy not even to notice. Like if a bunch of other changes are made and just one is missing in a big change list, your recipe could not be doing stuff and it isn't noticed right away, until CI starts failing or what have you, or your pull requests start being rejected for being incomplete. So know that you can opt out of these type validations in unit tests, and that you shouldn't. Right? Leave the type validation in there. That's important stuff. Okay, let's see. Was there anything else from this particular document that I wanted to mention? Yeah, so solution, provide type information via the class path. And the recommended way to do that is to use type tables and the class path from resources method. Now, you can use this Java parser .classPath method to look up by module name or artifact ID a particular module from the runtime class path of the recipe module itself. And so this works in most common cases, but it just has a couple downsides, right? Like if you're trying to make a migration like rewrite Spring that goes between multiple versions of the same library, only one of them can actually be on the runtime class path at a time. Technically, you can have multiple versions of the same dependency on the runtime class path at a time, but just the first one that the Java parser or Java compiler encounters is the one that will be used, and the others will be ignored. So, practically speaking, you cannot have multiple versions of the same library on the runtime class path at once. So you can't really use. Yeah, thanks to Sean. There are some nitty gritty details in here that are worth getting into at times when we want to do more than scratch the surface a little bit. So yeah, you can look up stuff from the runtime class path for your recipes, but that has some limitations. Also, this will get flagged by security scanners, right? Like Rewrite Spring is there to help you migrate off old versions of Spring, but a lot of corporate security scanners were flagging it as being vulnerable to various Spring issues because it had dependencies in old versions of Spring. It didn't actually run Spring. Those dependencies were not used. No code from them was invoked at runtime. They were just used to provide symbols to the parser, to provide type attribution to the recipe so that you would get a well-formed LST out at the end, but they'd get flagged anyway. And so the thing that was being provided to help you migrate off the old version was being flagged as having all of the problems that the old version had, which could make it hard to bring into corporate environments. And so we came up with this mechanism called type tables, which are a compact binary representation of the interface that any given jar Java class has. It just captures. It captures the method signatures without any of the implementation, right? And so these can be rehydrated at runtime into something that can be passed into the Java parser in order to produce well-formed types. And these are a lot smaller than a full jar. And so if we go look at something like, I've been talking about Rewrite Spring, but I have Rewrite Logging Frameworks open right here. There is, if you're using Gradle, there is this one of our build plugins that's just included by default in the recipe library one includes this recipe dependencies DSL, where you can add entries to parser class path, and note how you very much can have multiple different versions of the same jar here. And if I pop up in a terminal for this, get Claude running here. Let's just do a regular terminal. I'm big in this. Yeah, there we go. I'm big in. So I believe it is create type tables. No, I didn't remember off the top of my head. It is GW generate type tables. I don't remember the name of the task, apparently. Let's see, where'd it go? Is it in build? No, build setup, checking. No, not a help task. License. Oh, here we go. OpenRewrite. Create type table. Oh, I see. I pluralized it. That's why it is. I put that S on the end, and that's what like Gray will be confused. So if you run the create type table task, then it will resolve all the dependencies that are declared in this in this DSL, and it will create this file, this class path.tsv.gz file inside of source main resources, so that it will ship alongside your recipe jar and is then accessible via the class path from resources method. And this just knows to look at type tables to resolve this information. And if you're at all curious about how that works, or about the type table format itself, that is open source in the main OpenRewrite repository. If you just go look up class path from resources, you can look at this dependencies from resources implementation and see how this invokes type table from class path. Indeed, the whole type table file is here, where you can see how this is implemented and see what goes into the type table format if you are curious. Gzip input stream, all that good stuff. And so this is kind of a handy thing. And just musing aloud, one thing I've considered that we could do, that we don't do this yet, so this is just me speculating, not promising a new feature or anything, is we could capture type tables for all of the types and all of the dependencies in any given project that's parsed, and then all of that information could be available to recipes, which could be useful for a number of different purposes, right? Like one challenge of using Java template right now is it knows, like you can provide, like the recipe module can provide it types, but it's a little bit difficult to provide it types from the project, like from the LST that you're using it in. And so if you wanted to do a Java template, or like use Java template or use OpenRewrite recipes to like refactor project internals rather than like a library or platform version upgrade, it can be just difficult to get the types from the project that the recipe is operating on into the recipe. Like obviously you can write like a scanning recipe that collects stuff during the scanning phase, but like frankly you shouldn't have to. So that's there's some potential enhancements to the LST itself, which could come from this nifty type tables technology. And it is possible, although we don't usually do it, it is possible to generate type tables in Maven. And do we have, I think our Rewrite Recipe Starter Maven POM has an example of that. Rewrite Recipe Starter, of course, being our example recipe module. Yeah, so in the Rewrite Recipe modules, we of course tell the Maven compiler plugin to apply the dash parameters arg, which we always need, as that tells the Java compiler to include the names of method parameters in the bytecode, which is convenient for serialization and deserialization of recipes without having to add Jackson JSON info annotations everywhere, which repeat the name of the parameters. And then this -a rewrite Java parser class path from resources flag helps. And then let's see, do we? Yeah, here we go. So here's an example of using the Rewrite Maven plugin with a list of recipe artifact coordinates inside it, and you can tell Maven to do generate resources -p type table in order to tell the Rewrite Maven plugin to generate type tables. So type tables are something you could generate with Gradle or Maven, or we don't have a Bazel integration, but it'd be perfectly possible. You would just need to have some Bazel task that invoked the type table code. Okay, I think that is everything I had top of mind to share about type attribution in OpenRewrite. I will just share a link to this document, although I'm sure you could all find it if you were so inclined. So go peruse that at your leisure. We probably really should create a separate document just about type tables specifically, as they are an interesting subject that we reference in several places throughout our documentation, but don't have just like one page. It's like, what is a type table? Like I just explained it to you. So that is a primer on type attribution in OpenRewrite. And since I can't think of anything else to talk about at the moment, and we've gone for 45 minutes, I think that is a good place to end the stream. So thank you all of you for watching. Hopefully you found this to be useful. And I will be back here next week with Mark Heckler to talk about post-quantum cryptography, which sounds really cool and is about, oh, thank you to Sean for coming and commenting. But next week, when we're talking about post-quantum cryptography, that subject is about how do you choose or upgrade the algorithms you use for encrypting secure communications or encrypting anything else to be ready to perhaps pivot to new algorithms in a world where, powerful quantum computers might be cracking classical encryption keys faster than ever. And you would be like, oh no, we got to migrate to new encryption keys, or all of our banking operations are going to be effectively clear text for any bad actor or state who wants to pry into them. So come check that out. Should be a good discussion. And it will, for OpenRewrite recipe authors, we'll touch upon how to use data flow and taint tracking features, which we buffed up a little bit specifically for that purpose. So should be a good one. And I'll see you guys all next week. Until then, thank you for watching, and bye-bye.